Gemini 3.6 Flash costs 70% more per output token than GLM 5.2. That's $7.50 versus $4.40 per million tokens. And at high volume, that gap is real money, 750 versus 440, and it adds up fast. Both models just dropped and teams are already picking sides. So I went through official pricing pages, artificial analysis measurements, and community benchmarks, comparing GLM 5.2 versus Gemini 3.6 Flash across 5 dimensions. And every number I use is independently verified. GLM 5.2 wins on cost and reasoning, but there's one workload where that $3.10 output savings completely stops mattering. And if that's your use case, you might be picking the wrong model. We'll get to that in test 4. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. I went through every number both companies will actually stand behind, pulled the independent benchmark data, and I'm going to give you a straight answer on which one to use and when. You've probably heard both of these are solid Flash tier models, and yeah, they kind of are, but the gap between them is not zero. If you're running a high volume pipeline, pushing even 50 million output tokens a month, the wrong pick costs you $150 extra every single month. And that's what this comparison is actually about. Test 1 cost per token. I pulled the official list prices, and what surprised me is how fast the output side diverges. Output tokens drive most agentic bills. Every loop your agent runs, every long generation, that's output. And if you're running 100 million tokens a month, a $3.10 gap per million is $310 gone. I looked at 3 pricing dimensions here. On input, GLM 5.2 comes in at $1.40 versus Gemini's $1.50. Basically a wash. On output, GLM 5.2 is $4.40 versus Gemini's $7.50, which is that 70% premium. The one spot Gemini wins is cached input at 15 cents versus GLM 5.2's 26 cents. So if your workload is cache heavy, that flips a little. Take this with a grain of salt if you're cache heavy. Gemini's cache input rate at 15 cents per million is genuinely cheaper than GLM 5.2's 26 cents. And on deep infra, GLM 5.2 drops to 95 cents input and $3 output, so the gap gets even wider in GLM 5.2's favor depending on which provider you're using. GLM 5.2 takes test 1. The gap I found was 70% on output, which is not close at all. And for generation-heavy workloads, GLM 5.2 wins this on pure math. That's 1 for GLM 5.2, 0 for Gemini 3.6 Flash. Test 2, throughput speed. So 227 tokens per second is the number on screen right now, and it's Gemini 3.6 Flash's median from artificial analysis. When you're streaming a response to a live user and it stalls, they notice. And at 157 tokens per second versus 227, that gap is something you'd actually feel in a chat product. What I found here is pretty clear. Artificial analysis puts Gemini 3.6 Flash at 227.7 tokens per second median and GLM 5.2 at 157.5, which is about 45% faster for Gemini. Beziton does claim 280 plus tokens per second for GLM 5.2 on Blackwell hardware, but that's one specific provider, not the typical experience you get across the board. Gemini 3.6 Flash takes test 2. The Beziton peak number for GLM 5.2 is real, but it's not what most people will actually hit. And on consistent cross-provider speed, Gemini wins this one clearly. That ties it up, 1 for GLM 5.2, 1 for Gemini 3.6 Flash. That's 3, reasoning and benchmark scores. I know you've probably heard that benchmark numbers don't always predict real-world success, and that's fair, but an 89.5% score on GPQA Diamond is a hard number from an independent test. And when your agent gets a multi-step reasoning task wrong, that's a real failure with real consequences. What surprised me here is the ranking gap. Both models score close on the AA Intelligence Index, GLM 5.2 at 51 and Gemini 3.6 Flash at 50, but GLM 5.2 ranks number 2 overall and Gemini ranks number 25, which is a big positional difference for a 1-point gap. And I couldn't find a published GPQA Diamond score for Gemini 3.6 Flash at all. GLM 5.2 takes test 3. Honestly, the index scores are close enough that I thought this would be a wash, but the ranking difference and the missing Gemini benchmark data tell a pretty clear story. GLM 5.2 is the stronger reasoning model right now, and that puts GLM 5.2 up 2-1. 2 tests left, and this is where things shift, because test 4 is the one where GLM 5.2's cost advantage stops mattering entirely for certain workflows, and test 5 is where the coding benchmark gap between these two is actually pretty wild. Test 4, multimodal support. Say you're building a product that needs to process a user's uploaded video or handle a voice input You pick GLM 5.2 because it's cheaper. You build the whole thing, and then you find out it doesn't support video or speech input natively. That's a rebuild, and that's not a small problem. I looked at what each model actually accepts as input. Gemini 3.6 Flash handles text, image, speech, and video natively. GLM 5.2 is text-focused with some vision support listed, but speech and video are not there. Both models carry a 1 million token context window, so on that front, they're even, but the modality gap is real and it's not close. Gemini 3.6 Flash takes test 4. GLM 5.2's vision support turned out to be pretty limited, really just text with some image capability listed. And if your workflow touches video or speech at all, Gemini wins this with no contest. That ties the series back up. GLM 5.2, Gemini 3.6 Flash 2. Test 5, coding and agentic tasks. And this one's the tiebreaker. A62.1 on SW Bench Pro is the number I kept coming back to. That's a top tier open weights coding result. And if your agent is writing and fixing real code, this is the test that tells you whether you're going to get working PRs or broken ones. What I found here is a data gap that's kind of hard to ignore. GLM 5.2 publishes 62.1 on SWE Bench Pro and 81.0 on Terminal Bench 2.1. And I couldn't find any published SWE Bench or Terminal Bench numbers for Gemini 3.6 Flash. Gemini does cut output tokens by 17% versus its predecessor, which is a real cost lever, but that's not a quality score. You can compare it directly. GLM 5.2 takes test 5 at the series. The fact that Gemini doesn't have any published coding benchmark numbers to compare against is itself a signal, and GLM 5.2's 62.1 SWE Bench Pro score stands alone here. That's 3 for GLM 5, 2 for Gemini 3.6 Flash. So here's where GLM 5.2 clearly wins. Output tokens are $4.40 per million versus $7.50, which is 70% cheaper for generation-heavy work. It ranks number 2 on the AA Intelligence Index, number 1 among open weights models. It publishes 62.1 on SWE Bench Pro and 81.0 on Terminal Bench 2.1, and open weights means you can self-host. And here's where Gemini 3.6 Flash clearly wins. It generates at 227.7 tokens per second median, about 45% faster than GLM 5.2. It handles text, image, speech, and video input natively. Its cached input rate is 15 cents per million versus GLM 5.2's 26 cents. And it's fully managed with a March 2026 knowledge cutoff. All right, so the overall result. The 70% output token gap is just hard to argue with for most workloads. And I think that's what decides this. If you need video or speech input, pick Gemini 3.6 Flash. It's the only one that can actually do the job. If you're running high volume text or coding pipelines, GLM 5.2 at $4.40 per million output tokens is the clear call. I ran GLM 5.2 against a frontier reasoning model next. And the cost story gets way more interesting when you're comparing open weights against closed, because the gap doesn't always go the same direction. That comparison is already on the channel if you want to keep going.